Hey mathematicians, Caitlin Henderson here with another lesson video. This is the last lesson video of Unit 7 and we are talking about coordinate proofs. This is not the same type of proof that we did in the last lesson. This is proving different aspects of coordinate geometry using the formulas and definitions we have learned so far. So let's get started. First up, we learned about the distance formula, and we use the distance formula to find the lengths of triangles. Well, in this case, we want to prove that a triangle is either an equilateral, a isosceles, or a scalene. So we have this triangle here, and if you remember from our definition video, an isosceles triangle has two sides that are the same length. A scalene triangle, all three are different, and then an equilateral, all of them are the same length. In order to figure this out, what we need to do is identify the length of each one of the sides and then compare. I'm going to slide myself on over so we've got space to work. Now, to identify the length, there's a couple things you could do. You could create right triangles and use the Pythagorean theorem. This is a great example here of two sides that we could create, right? These right angles here, and easily measure that this is 3 and 1, and easily measure that this is 3 and 2, right? Or we could use the distance formula, which just takes the location of each one of the points. Now, I'm going to first do this with the distance formula, and then we can talk about the Pythagorean theorem next. And then when you get assessed on this, you can choose whichever way you like best. Now, first and foremost, I am going to label my triangle. Currently, it's not labeled, and I just want to know what my coordinate location is for each one of these sides. So A here is located at x is 1 and y is 4, so 1, 4. And B here is located at x is 4. Move myself to do that. X is 4 and y is 3. And then C is located at 1, 1. Now, if you notice, this is a pretty nice triangle because I don't need to do it with all three sides because we have a vertical length here. Vertical lengths are super easy to calculate because we can just hop, skip, and jump to measure the distance between them. So you can see here, these darker lines are the 1 unit measure. So I can go 1, 2, 3, and see that this is 3 units in length here, okay? So what I need to do is just find the length of my other two sides. Now, for my first side, let's find AB, okay? I am going to have the point B be my x2, y2, and my point A be my x1, y1. What we're going to do is we have the distance formula here, and we are just going to plug in the values. But remember, the first thing I always like to do is write my distance formula so I make sure that I'm not missing anything when I'm writing it down. Okay, y2 minus y1 all squared. So my x2 value is going to be in my second point, which I said is B here. So x2 is 4. And we're subtracting x1, which is 1. And then we're adding, we have y2 here, which is 3, and we're subtracting that from y1, which is 4. Okay, so this is our value or our equation when we have replaced all of the values. Now, PEMDAS tells me that first I need to take care of everything inside the parentheses. We're just doing a simple subtraction. So you can plug it into your calculator or you can calculate it in your head. But we have 4 minus 1. 4 minus 1 is 3. And this next one, I highly suggest when you're working with negative, making sure you're double checking. But we have 3 minus 4, and I know if I were to plug that in my calculator, I would get -1, okay? But don't be afraid to double check because calculation errors are kind of a bummer when you have to mark question or answers wrong. So next thing PEMDAS tells me to do is exponents. So we're going to do this 3 squared. 3 squared is 9. And then remember, when we're doing the square root of negative numbers, you can just get rid of the negative and just do the number itself, because -1 times -1 is 1. 1 times 1 squared is also 1. So we have 1. That means that we have 9 plus 1, which is equal to the square root of 10. The length here is square root 10. Now, sometimes you're going to be asked to round to the nearest tenth. Remember, nearest tenth is talking about if we have a number here, we only want one number after the parentheses. So what I can do is get out my handy dandy calculator here, and I am going to type in 10 and find the square root of that. And that gets me 3.16227766. Okay, we only want the second point. So if we have 3.16277, okay, super long number. We only want this value right here. This is the 10th place, okay, 10th. Then we've got the hundredths, and it moves on, so on and so forth. If you're getting asked to do the 10th place, this is the only one you want. So you look next door and you ask yourself, is this number 5 or bigger or 4 smaller? This is a 6, so it's bigger. So if we were asked to find it, the value in the nearest tenth, we would erase everything, round our 1 up to a q, because there's a 6 after it. So this is, and not equal to, it's about equal to 3.2. Okay, now our last side we need to find is our length of BC. So just like before, I'm going to start with, we've got this BC, we're going to use the distance formula here to find the length of it. And the first thing we're going to do after writing down our equation is to replace all our x2s, x1s, y1s, and y2s. So first and foremost, I am going to make B this time be my, well, it was the second point last time. I'm going to make it the second point this time. So just because I'm going to have less negatives to work with. So that means that my x2 is going to be 4, and my y1, or my x1 is going to be C here. And remember, you can always do, if you need help remembering, if this is my second point, these are my values and these are my values. So it just kind of helps you make sure that you are plugging everything in correctly. So we've got our x2, we're going to subtract our x1, which is 1s, and then can't forget the square part. And then we're going to take our 3 and we're going to subtract 1 again, because our y value over here is 1. Now, PEMDAS tells me, remember, PEMDAS is order of operations. Please excuse my dear Aunt Sally. And it tells me parentheses, and then exponents, then multiplication and division from left to right, and addition and subtraction from left to right. So I'm going to take care of everything inside my parentheses first. So 4 minus 1 is 3. We haven't taken care of the square yet, or the plus. And then 3 minus 1 is 2, so we are going to square that. PEMDAS then tells me that the next thing I want to do is my exponents. 3 squared is 3 times 3, which is 9. And then 2 squared is 2 times 2, which is 4. And this gives us, now there's no multiplication, so we skip down to addition and subtraction. 9 plus 4 is 13. So this is the square root of 13 here. And then if we're asked to round our answer to the nearest tenth, what I can do is plug in the square root of 13 into my calculator. Square root of 13 gets 3.60555, okay? But tenth means we just want a number here. We don't want anything after this. So we have to go next door and ask ourselves, is our number 5 or greater, 4 or less? It's 0, so it's 4 or less. So this time it just drops right off, and I am left with 3.6, about 3.6, okay? So the question is, what type of triangle am I working with here? Now, we have our side measures. We have 3 units. We have, here, let me add my little unit. We haven't really focused that much on the units, but there's still a good thing to have on there. So we have 3 units, 3.2 units, and 3.6 units. we don't have a single side that is equal in length. So that means that we have a scaling triangle. Scaling, meaning all of our sides are not equal to each other. Okay. Now, let's say that you do not love the distance formula, but you really do enjoy the Pythagorean theorem. I'm going to erase all this here. Let's talk about how we would solve for this triangle if it's, scaling isosceles or equilateral based off of using the Pythagorean theorem. Now, once again, this one is still just 3 units. It's very easy to calculate because it's a vertical line. Now, if we wanted to use the Pythagorean theorem here, what we need to do is create right triangles around every side that's diagonal. And we only have 2 here. And what we want to do is find the length of our sides. We have 3 and 1, and we have 3 and 2. And then instead, remember the Pythagorean theorem is a squared plus b squared equals c squared, okay? We can use this formula to calculate our length. So our first one here, and remember this was AB and this was BC. So our first one here, AB, we would plug in the values into the Pythagorean theorem. Doesn't matter which one's A and doesn't matter which one's B. I'm going to just say that this one's A and I'm just going to say this one's B. Okay, doesn't matter which one's which though. So we start with a squared plus b squared equals c squared. And we replace the a with a 3. We replace the b with a 1. And we don't know c squared yet. So that is going to stay a c squared. PEMDAS tells me we've got no parentheses. So we're going to move on to exponents. 3 squared is 3 times 3. And 1 squared is 1 times 1. So this is 9 and this is 1. And so c squared is equal to 10. But remember, we want the square, or we take the square root of both so that we can get the value of c itself. And additionally, when we were solving for this, we did get square root of 10 in the prior. It would be the same here, okay? We would get the square root of 13 here because we have 3 squared plus 2 squared, which is 9 plus 4, which is 13, right? And it would still show that we'd have different side lengths. But that's how you do it if you were using the Pythagorean theorem. Okay, so for this next slide, what we want to do is show that a point lies on the circumference of our circle, okay? So remember that when we are working with circles, by definition, and that's, sorry, not a great circle, but by definition, the distance from the center to the outside of a circle doesn't matter where it lies. This distance, which is called the radius, okay, is always the same length. So here we have a circle where their center is located at 2, 2. Okay, and they have a radius of 1, which means the distance from the center of the circle out for all of these should be 1. Now the question is, does this point lie on this circumference right here? So we want to know, does point A lie on that circumference? And to calculate this, we want to know, what's the distance? The distance should be 1, but we're not 100% sure if that distance is in fact 1. To do that, we are going to identify what is our first and what is our second point going to be. I'm going to make this one 0.2 and I'm going to make this one 0.1. Okay, I'm going to use my distance formula. D equals square root x2 minus x1 squared plus y2 minus y1 squared. Okay, I'm going to replace my values using substitution here. My 0.2, my x value is 2, and my y value, my x2 is 2, and my x1 is 1. So we're going to plug in, or 1.2. There we go. Oh, goodness. Okay, and then our y2 value is also 2, and our y1 value is going to be 2.6. We still are working with these squared values here. Okay, we are going to take care of the inside of our parentheses by simplifying 2 minus 1.2, plug it into your calculator, and you're going to get 0.8. And then if we do 2 minus 2.6 in our calculator, we're going to get negative 0.6. Okay. Now we've got the single values on the inside. We are going to take the square root. The square root of 0.8 is 0.64. And the square root of negative 0.2, remember we can drop that, or negative 0.6, we can drop the negative, we just do 0.6 squared, which is going to be 0.36, okay? Next, we can go in and add these values together, and guess what we're going to get? We're going to get 1. And if you plug in the square root of 1 into your calculator, you're going to find is 1. We have the radius of 1, so then it is true that the point A, 1.2, 2.6, is located on the circumference of the circle. Okay. Our next example is finding slope. We have talked about slope many, many, many times, but let's talk about, go through it really quickly, just to make sure that you understand how to find it and how to find slopes parallel and perpendicular to a line. So first and foremost, remember that to find slope, we look at this rise over run, which is this change in y over change in x. And we do that by taking 2 points, identifying the x or the first point and the second point, and then subtracting them from each other. So in this case here, we have the point 1, 1, and we have the point 3, 2. Okay, so if I were to find the slope of this, I'd say, well, I'm going to make this one 0.2, and I'm going to make this one 0.1. And so that means that we have x2, y2, and x1, y1 here, okay? And we plug it into this equation. So our y1, our y2, we want y2, our y2 is going to be 2, and we subtract that from y1, and our x2 is going to be 3, and we subtract that from our x1, so we get 2 minus 1 over 3 minus 1. We can simplify the top, we have 1, and we can simplify the bottom, and we have 2. So that means the slope here is 1/2. Now, if I were asked to find the slope of a parallel line, remember, slopes are equal. So I would just plug in 1/2 all over again, okay? Now, perpendicular lines are a little bit more tricky. Now, remember, we said that if the slope was equal to a whole number, like 2, we could plug it into this formula here, where we take the slope of the perpendicular line, and we just put in this, remember, slope is equal to m. Okay, slope is equal to m. M is the letter we associate with slope. Okay, and so we can just take this m value, plug it in, and we would get negative 1/2 if our slope was 2. We're talking if our slope was 2. Now, in this case, our slope is 1/2. Okay, and I just find that this is not the most friendly formula when we're working with fractions. So my suggestion is doing the flip and switch, which is flipping the signs or flipping the numerator and denominator and then switching the signs. So in this case, right, I'm flipping, so my numerator, which is 1, is now going to become my denominator. My denominator, which is 2, is now going to become my numerator. So we have 2 over 1. And then this is positive, so we need to switch the sign here so that they're negative. Remember that 2 over 1 is the same exact thing as 2. So that means that our slope of a perpendicular line here, our slope of a perpendicular line, this line specifically, is negative 2. Okay, so if I were to basically cut this line, this would be the perpendicular line right here, okay? Because that one has a slope of negative 2, okay? Remember that parallel lines have equal slope. We can use this formula, or we can do the flip and switch of the perpendicular line if we're working with a fraction. If we're starting with fraction, we can flip them and then switch the signs. This is how we find the slope of lines. Now, how are we going to use it? First, let's talk about the key identifiers of different shapes. There's a whole bunch of these in your text, but ultimately parallelograms, rectangles, squares, rhombus, they all have specific characteristics, and we can use these characteristics to identify if points make one of these shapes. Now, remember, parallel lines, our parallelograms have parallel lines that are, opposites. are parallel, and congruent. Opposite angles are congruent. Consecutive angles are supplementary, which when we're working with lines isn't quite as important. Okay, rectangles, opposite sides are congruent, opposite sides are parallel. All four angles are equal and opposite sides are congruent. And then squares, remember, all sides are congruent, opposite sides are parallel. Opposite sides are congruent because they're all four congruent, and then opposite angles are congruent. So there's certain properties that we can work with. So if we're asked, is a quadrilateral a parallelogram? Ultimately, what we want to do is use that identifier that opposite sides are parallel and congruent to figure out if it is a parallelogram. To do this, we need to see what is the length of each one of our sides. And we are going to break this down using our distance formula. Now, remember, our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, that's our distance formula, and we're going to do it for each one of our sides. So let's start with side AB here. And I'm just always going to make the second point be my point 2. So B is going to be my point 2. And I am going to start with my distance formula, x2 minus x1 squared plus y2 minus y1 squared. Okay, that's what I'm starting with here. And I'm going to replace my x's and my y's with their appropriate sides. Remember that we have here, this is going to be my x1 and this is going to be my y1, right? x2, y2. So my x2 is 2, my x1 is 1. We still have squared. My y2 is 3, and my x2 is, or my y2 is 3 and my y1 is 2. Do you see why we write it down? It is even so confusing just speaking it. So PEMDAS tells me I'm going to take inside the parentheses first. So we have 2 minus 1, which is 1 squared, and we have 3 minus 2, which is 1 squared. We can now take and they should all have equal signs because they're being equal to the length of AB. Here we go. Okay, so we've got 1 squared is 1, 1 squared is 1, and so we have the square root of 2. Now, we are talking length, unless it says you need to calculate the length in decimal form, where we're going to tell you tenths, find it in the tenths place. This is fine. You can leave it just like this. Now let's do the same thing with BC. Okay, so we always start with our distance formula, x2 minus x1 squared plus y2 minus y1 all squared. Okay, we replace the values because we can due to substitution. I'm going to have C be my second point. So we're working with 5 minus 2 squared plus 2 minus 3 squared. Okay. And now we do the inside of the parentheses. So 5 minus 2 is 3. And 2 minus 3 is negative 1. We can now take care of the exponents. 3 squared is 9. Negative 1 squared is the same as 1 squared, which is 1. And we now have the square root of 10. Okay, we have found the distance for each one of our first sets of points here, our distance for each one of the points here. And so we have, in this case, right, the first sets of lengths, because parallelograms, opposite sides are congruent. Let's see if we can get the opposite sides or any of the sides to be congruent here. Okay, our next set of sides we need to figure out are CD and DA. Okay, these are our last sets of sides. We don't know what the lengths are of those. So to do that, we're going to do the exact same thing. We're going to start with the parallelogram, or we're going to start with the distance formula of x2 minus x1 squared plus y2 minus y1 squared. And I can do that here with this one. Might as well just get the hard part out, which is writing this very long equation, at least hard for me because I'm using a mouse here. Okay, let's start with CD. Now I'm going to have D be my point 2 just because that's what I've been doing so far, and it just keeps things nice and organized for me. So D is my point 2, so we're going to do 4 minus 5, 4 minus 5 squared, and then we are going to do 1 minus 2 squared, okay? That gets us 4 minus 5 is 1 squared, 1 minus, negative 1 squared. Can't forget that negative sign. 1 minus 2 is negative 1 squared. So we're left with negative 1 squared plus negative 1 squared. We take care of the squares. Remember, negative 1 times negative 1 is just 1. And that's the same for both. And now we have square root of 2. Okay, beautiful. We have the first step to proving a parallelogram, which is these opposite sides are going to be congruent to each other. Now, next step here, let's figure out for dA. Okay, so we're going to replace values. D is going to be my 0.1 and A is going to be my 0.2. Is that how I want to do it? Yeah, 0.1, 0.2. So X is going to be 1 minus 4 squared. And Y is going to be 2 minus 1 squared. Okay. So we take care of the inside. 1 minus 4 is negative 3 squared. And 2 minus 1 is going to be 1 squared. Take care of the square root. Negative 3 times negative 3 is going to be 9. 1 times 1 is 1. And we've got square root of 10 again. Okay, so we've got some congruent sides here. Okay, but that's not the only thing we need to make sure. The other thing we need to make sure is, are our sides also parallel to each other? So we need to have same slopes. So we know we have congruence, perfect, but we need to know if they have the same slopes. Okay, now that we have shown that we have congruent sides, we next need to show that these sides are in fact parallel to each other. And remember, to show that things are parallel, we need to show that they have the same slope. So we're going to use our slope formula, which is our rise over run, which is our change in, whoops, not x first, y first. So we do x or y2 minus y1 over x2 minus x1 to solve for this. And we can solve for each one of our side lengths. So for AB here, okay, I am going to have, once again, B be my second point here. So I am going to write y1 minus y2 over x. Not 1, 2. 2 here. We start with the second point. And realistically, it doesn't matter in the big scheme of things as long as you're putting them in the same order each time. But the equation itself has 2 first. So I am going to have my y2 point be 3, and I'm going to subtract it from 2. And then we have 2 minus 1. So that gives us a slope of 3 minus 2 is 1. 2 minus 1 is also 1. So our slope here is going to be equal to 1. If we have parallel sides, we want our slope of CD to be the same. So we have y2 minus y1 over x2 minus x1. Okay, that's a 1. So for CD here, I'm going to have D be my first point, or my second point. So we're going to do 1 minus 2, and we are going to do 4 minus 5. That is going to get us 1 minus 2 is going to be negative 1. 4 minus 5 is going to be negative 1. Negative 1 over negative 1, we can cancel out these negatives. We have 1 over 1. That means that our slopes are the same. Okay, So m is equal to 1 and m is equal to 1. Yay. Okay, we've got the first, or the second to last step. Let's do one more thing to confirm it. Let's look at the slope of BC and DA. Okay, actually, I'm going to give myself just a smidge bit of room there. So BC, we're going to look at y2 minus y1 and x2 minus x1, where C is going to be my second point. So that means that we are working with 2 and 5, right? 2 and 5. And B here is going to be my first point. So that is going to be what we're subtracting, and that's a 3 and a 2. So 2 minus 3 is -1. 5 minus 2 is 3. So we have a slope of -1/3. Lastly, let's check DA here. Okay, y2 minus y1, x2 minus x1. Okay, my A is going to be my second point. So that means we have a 2 and a 1 that we're working with. And then D is going to be my first point, and we have a 1 and a 4 that we're working with. Okay, 2 minus 1 is 1. And 1 minus 4 is -3. This is the same thing. It doesn't matter which one has the negative on top. Realistically, when we write it, we usually put it either on the side or on top. But this is the same thing. One of the values is negative, so we have a -3 for both. Is the shape a parallelogram? We have opposite sides are congruent, and we have opposite sides are parallel. Therefore, we do, in fact, have a parallelogram. Alrighty, guys, we have proven quite a few things here. We have proven what type of triangle we're working with. We have proven that a point lies on a circle. There might be some examples in asking, is a shape a square, right? If we want to prove that a shape is a square, all sides need to be congruent, opposite sides need to be parallel, right? To prove if a shape is a parallelogram, opposite sides need to be congruent, and opposite sides also need to be parallel, right? These are all things that we're kind of proving. So go through, review the lesson, and do the practice problems. If you have any questions, please reach out. But until next time.